New Syllabus Mathematics Book 1, updated 7th edition, Chapter number 2, Exercise 2a, Question number 7. Absolute zero, defined as 0 Kelvin, is the theoretical lowest possible temperature. This corresponds to a temperature of 273.15 degrees Celsius below zero. Represent this temperature using a negative number. Now, absolute zero means a 0 Kelvin is the lowest possible temperature, representing a point where the particles, that is, atoms and molecules in a substance, would have minimal vibrational motion. It is theoretically the point at which all thermal motion ceases. However, in practice, reaching absolute zero is impossible, but scientists can get very close to it in controlled laboratory conditions. So, to express absolute zero temperature in degrees Celsius, simply I'll subtract 273.15 degrees Celsius from 0 Kelvin. The conversion formula is temperature in Celsius degree is equal to 0 Kelvin minus 273.15, which is equal to negative 273.15 degrees Celsius. This is the formula used to convert temperature from Kelvin to Celsius. So if I subtract 273.15 from 0, we get a negative 273.15 degrees Celsius. Therefore, the temperature of absolute zero in Celsius is negative 273.15 degrees Celsius. This is the negative value corresponding to 0 Kelvin. Second part from this question is, the lowest point in the North America is the Badwater Basin, which is 86 meters below sea level. Represent this altitude using a negative number. The Badwater Basin is located in Death Valley, California, and its elevation is 86 meters below sea level. To represent this altitude using a negative number, since it is below sea level, the negative sign indicates the depth beneath the reference point, that is sea level. Therefore, the altitude of Badwater Basin is negative 86 meters. This negative value shows that it is 86 meters below the sea level of the ocean's surface. Moving on to question number 8, the statement of the question is as follows. Fill in each box with greater than or less than symbol. Now, first part is negative 4 and negative 6. As we know that the more you move towards negative numbers, the lower the value of the number. Therefore, I will put the greater symbol between negative 4 and negative 6, and I will read it as negative 4 is greater than negative 6, or negative 6 is less than negative 4. The second part is negative 11 and negative 11.5. Remember, on number line, the further left you go, the smaller the number. Since negative 11 is closer to 0 than negative 11.5, therefore negative 11 is considered greater than negative 11.5. Third part of the question is 1 over 5 and 1 over 3. To fill the box with greater than or less than symbol, first let's find out which one is greater. I will find the least common multiple LCM of 1 over 3 and 1 over 5. The least common multiple LCM of the denominators 3 and 5 is 15. To make the denominators the same, first I will multiply both the numerator and the denominator of the fraction 1 over 3 by 5, which gives us 5 over 15. Next, I will multiply both the numerator and the denominator of the fraction 1 over 5 by 3, which gives us 3 over 15. Now, the denominators of both fractions are the same. So let's check out their numerators. 5 over 15 is equal to 1 over 3, and 3 over 15 is equal to 1 over 5. As you have noticed, the numerator 5 is greater than the numerator 3. Therefore, the fraction 1 over 3 is greater than 1 over 5, or 1 over 5 is less than 1 over 3. Therefore, I will put the less than symbol between 1 over 5 and 1 over 3, and I will read it as 1 over 5 is less than 1 over 3. The fourth part is negative 1 over 3 and negative 5 over 6. To find out which one is greater, I will make their denominators the same. The LCM of the denominators 3 and 6 is 6. If I multiply both the numerator and the denominator of the fraction negative 1 over 3 by 2, we can get the fraction negative 2 over 6. As you have noticed, the denominators of both the fractions are the same. Now, let's check out their numerators. The numerators are negative 2 and negative 5. Since negative 2 is greater than negative 5, therefore, the fraction negative 1 over 3 is greater than negative 5 over 6. Therefore, I will put the symbol greater than between negative 1 over 3 and negative 5 over 6, and I will read it as negative 1 over 3 is greater than negative 5 over 6. Now moving on to question number 9. The statement is as follows. Use a number line to illustrate each of the following numbers. The first part is negative 1 over 3, 2.5, 1 whole 3 over 8, 1, negative 0.2, and 0.11. The smallest number is negative 1 over 3, while the largest number is 2.5. So here is the number line from negative 2 to positive 4. The first number is negative 1 over 3. If we divide negative 1 by 3, we get approximately negative 0.33. On the left of 0, I have divided 0 and negative 1 into 10 equal parts. I can consider these small divisions negative 0.1, negative 0.2, negative 0.3, negative 0.4, negative 0.5, negative 0.6, negative 0.7, negative 0.8, and negative 0.9. Or I can consider them as negative 0.10, negative 0.20, negative 0.30, negative 0.40, negative 0.50, negative 0.60, negative 0.70, negative 0.80, and negative 0.90. It's your choice, because negative 0.1 is equivalent to negative 0.10. Negative 0.2 is equivalent to negative 0.20, and so on. Now, negative 1 over 3 or negative 0.33 is slightly less than negative 0.30 or negative 0.3, because negative 0.33 is less than negative 0.30. So here we have negative 0.10, negative 0.20, negative 0.30, and then negative 0.33, which is very close to negative 0.30. Next is 2.5, which lies between 2 and 3. The third point is 1 whole 3 upon 8, which is equal to 1.375. To illustrate 1 whole 3 over 8 or 1.375, I will divide positive 1 and positive 2 into 10 equal parts. And I will consider each small division equal to 1.100, which is equivalent to 1.10 or 1.1. So here we go. The first small division is 1.100. The second small division is 1.200. And the third small division is 1.300. Since 1.375 is slightly closer to 1.400, therefore I will place 1.375 just before 1.400, which is the correct place for 1.375 or 1 whole 3 upon 8. The fourth number is 1, which is exactly 1 unit to the right of 0. The fifth number is negative 0.2. It's simple. Since the first small division on the left side of the 0 is negative 0.1, therefore the second small division on the left side of the 0 is negative 0.2. The last number is 0.11. Let's consider the first small division on the right of the 0 as 0.10. Since 0.11 is slightly to the right of 0.10, therefore this is the right place for 0.11. The second part of the question is to illustrate positive odd integers less than 20. It's very simple to illustrate. The positive odd integers less than 20 are 1, 3, 5, 7, 9, 11, 13, 15, 17, and 19. The following numbered line shows positive odd integers less than 20. The third part is prime numbers greater than or equal to 2 but less than 10. Now prime numbers greater than or equal to 2 but less than 10 are 2, 3, 5, and 7. The following number line shows prime numbers greater than or equal to 2 but less than 10. The fourth part is to illustrate the common factors of 12 and 16. So let's factorize 12 and 16. Factors of 12 are 1, 2, 3, 4, 6, and 12. Factors of 16 are 1, 2, 4, 8, and 16. Common factors of 12 and 16 are 1, 2, and 4. And the following number line shows the common factors of 12 and 16.